With your help, we've prepared for a successful space mission. Now it's time to plan for re-entry into the Earth's atmosphere. Just like with payload limits and oxygen amounts, re-entering Earth's atmosphere has specific requirements that must be met to ensure the safe return of the astronauts. To re-enter Earth's atmosphere, a rocket's speed can't be more than 7,500 meters per second. The rocket will be traveling around 10,000 meters per second when it begins to slow down. There's a 3-second delay on the retrothrusters, which accelerate the rocket at a rate of negative 200 meters per second squared. The current mission plan tells the crew to hit the retrothrusters when the rocket is 8 seconds out from the Earth's upper atmosphere. It's our job to figure out whether this is enough time to hit the desired speed. The engineers have given us this inequality to model the rocket's re-entry. 10,000 minus 250 times the quantity t plus 3 is less than or equal to 7,500. What do you notice about this inequality? It has parentheses. Let's practice solving some similar inequalities before we tackle this one. Take a look at this inequality. Negative 3 times the quantity 2x minus 1 is less than or equal to 5. Given what you know about solving equations with parentheses, what should we do first to begin the process of solving for x? Right, we need to simplify, which in this case means we're going to distribute this negative 3. Well, wait a second, this is an inequality, and I'm multiplying by a negative. Do you think I need to flip this inequality symbol? No, remember, distributing doesn't change the value of this expression. It just changes how it looks, so we won't change the inequality symbol. Negative 3 times 2x is negative 6x, and negative 3 times negative 1 is positive 3. So now the expression on the left is negative 6x plus 3. Is this completely simplified? Yes, there are no other operations to do on the left, so we're ready to solve for x. I'll start by subtracting 3 from both sides, which gives me negative 6x is less than or equal to 2. Then I'll divide both sides by negative 6, which gives me the solution x is greater than or equal to negative 1/3. Try this next example on your own. Pause the video, then come back to check your work. The left side of this inequality needs to be simplified. I'll start by distributing 3. That gives me 15h plus 3 minus 2h. 15h and negative 2h are like terms on the same side of the inequality, so I will combine these terms to make the inequality 13h plus 3 is greater than or equal to 42. Subtract 3 from both sides, then divide both sides by 13, and the solution is h is greater than or equal to 3. I think you're ready to solve this inequality for our engineers. If you're feeling confident, pause the video and try this on your own. Or you can just work through this with me. The left side of this inequality needs to be simplified. Let's start by distributing this negative 250. Negative 250 times t is negative 250t, and negative 250 times 3 is negative 750. Do you see any like terms we can combine? Yes, we can combine 10,000 and negative 750, which gives us 9,250 minus 250t is less than or equal to 7,500. Next, we subtract 9,250 from both sides. That leaves us with negative 250t is less than or equal to negative 1,750. Divide both sides by negative 250, which means we flip this symbol and get the solution t is greater than or equal to 7. Let's take a closer look at what this solution is telling us. So, remember, the current mission plan tells the astronauts to start the retro thrusters 8 seconds out from the Earth's atmosphere. Will 8 seconds be enough time to slow our rocket and reach a safe speed? The question we're really asking is 8 seconds in the solution set of the inequality? How do we know? Well, the solution set of an inequality is the set of all values that make the inequality true. So, if 8 makes the inequality true, we can say 8 is in the solution set. The solution we just found says t must be greater than or equal to 7 seconds. When I substitute 8 for t in this solution, does the inequality stay true? Yes! So what does this tell me? 8 is in the solution set for this inequality, and 8 seconds is enough time to slow the rocket to a safe speed. Whew! Try these two examples. Determine whether the given values are included in the solution set of each inequality. Pause the video now. So this first example has a solution set where m can be any value greater than or equal to negative 47. Is negative 156 greater than negative 47? Nope. So negative 156 is not in the solution set for this inequality. What about this second example? The number line shows the solution set of values greater than 102. So, is 103 greater than 102? Yes, we can see 103 is in the solution set because this pink line extends above 103. Even though we only tested one value in each of these examples, both solution sets represent a vast number of possible solutions to these inequalities, all of which make these inequalities true. Today, we practice solving inequalities that require simplifying first, using distribution and combining like terms. We also revisited what it means for a value to be included in the solution set of an inequality. Make sure you finish up these guided notes before you attempt the online practice. And remember, math is everywhere. Keep exploring.
Hey, hey.